Today we're going to learn how to use scientific notation and how to make scientific notation. So after this lesson, you're going to be able to write numbers using scientific notation, express numbers written in scientific notation in standard form, and when I'm giving you two numbers written in scientific notation, you're able to identify how many times as much as one is than the other. So what we're going to be doing is we're going to be reading this word problem, and then we're going to answer a series of questions designed to help us rewrite a number as a product of a number between 1 and 10 and a power of 10. So we're going to write large numbers in scientific notation. So let's take a look at this problem right here. It says, up top in the bold, it says, you've learned about practice value and investigated multiplying and dividing by powers of 10. Now take a look at this problem. The planet Venus is more than 60 million miles from the sun. Write the number as a product of two factors, a number greater than or equal to 1 but less than 10, times a power of 10. Okay, so this is symbolic of how we're going to write it. So in this side of the multiplication sign, it's going to be a number greater than or equal to 1 but less than 10. So that's 1 through 9. Or it can be a decimal point as well. And you're going to multiply that by a power of 10, and this can be any number between 0 and infinity. Okay, so down here it says use the math you already know to solve the problem. What we've been working on so far is identifying this number here. Okay, this number is 60 million, so that's what I'm going to write. Okay, and then it says fill in the missing factor 60 million. So I'm going to say it's 6 times 10 million. And that's all I did. Okay, now it says write the second factor in the equation as a product of tens. So this is my factor, and then this is the amount of tens I had to multiply in order to get this answer. So what I essentially did was I took this number and I broke it down. Now letter D says write the second factor as a power of 10. Explain your reasoning. I count my tens. I have 1, 2, 3, 4, 5, 6, 7 tens. So that means that 10 is used as my factor 7 times and can be written as 10 to the 7th power. Let's take a look at letter E. Explain how you could write 60 million as a product of a number greater than or equal to 1 that is multiplied by a power of 10. So what this is asking is, how am I going to write 6 to multiply to this 10 to the 7th power? We're going to write the number as 6 multiplied by a power of 10. The answer is going to look similar to this. 60 million equals 6 times 10 to the 7th power. Let's go on to page 31 to where it says find out more. Okay, scientific notation is another way to write numbers. Numbers written in scientific notation is equal to the same number in standard form. Numbers written in scientific notation have two parts. Note that the first part, right here, will only have one digit to the left of the decimal because the number will be less than 10 and greater than or equal to 1. Let's write the number in scientific notation. Okay, so we have 60 million, and we're going to write that in scientific notation. Now that we understand how to write numbers in scientific notation, let's look at how we're going to change scientific notation back to standard form. It says to write the number 3 and 5400ths times 10 to the 5th power in standard form, we move each digit in 3 and 5400ths up 5 place values by moving the decimal point 5 places to the right, because we're multiplying by 5, by 10 to the 5th power. So I'm going to move my decimal 1, 2, 3, 4, 5 places to the right because I'm multiplying 10 to the 5th power. To translate scientific notation and standard notation, change the place values of the digits by moving the decimal point according to the power of 10. So that means if this power here is 6, I move my decimal place 6 places. If this decimal place is 7, this exponent says 73, I'm going to move my decimal place 73 places, which probably will go on forever. And so make sure when you're doing scientific notation, pay special attention to your exponents. Below, number 1 says reflect. Write 6 and 8500ths times 10 to the 8th power in standard form. Show your work. That means I'm writing this in standard form. That means that's the number with my commas in it, okay? Like as if I was reading it. So 6 and 85th hundredths times 10 to the 8th power is 6 with my decimal and my 8 and my 5. Okay, I start off with what I already have here. Then I'm going to move my decimal place 8 places to the right. My decimal place ends here. So now I have to write it in standard form. That means this new number is what this number is. I changed my number because I moved my decimal to over here. And so this is what that new number becomes. Now that we've reviewed that, we're going to learn about writing numbers in scientific notation with positive and negative powers of 10. We're going to write small and we're going to write large numbers using scientific notation. Let's read this problem below and then explore on how to write very small numbers using scientific notation. 7 nanoseconds is equivalent to 7 1/1000ths of a second, or 7 1/1000ths. We read this as 7 1/1000ths. Write 7 1/1000th in scientific notation. Let's picture it real quick. Let's take a look at this chart. How many patterns do you see? Let's read through the numbers together. 100 is 10 times 10. That's 10 to the 2nd power. 10 is 10, which is also 10 to the 1st power. 1 is 1, and that's 10 to the 0th power. Notice the pattern of how many zeros there are with our positive integers. Now let's take a look at here. We have 1/10, okay, which is also 1/10, and that is 1 over 10 to the 1st power. And if we convert that into an inverted power, that is 10 to the negative 1st power. Let's take a look at our next one. We have 100th, okay? That can also be written as 1 over 10 times 10, or 1 over 10 to the 2nd power, because there's 2 10s over here, so there's a 2nd power now. We can invert that and also write that as 10 to the negative 2nd power. Let's look at our next one. This is 1,000th. That means it's 1 over 10 times 10 times 10, which is 1,000. It can also be written as 1 over 10 to the 3rd power. Or if we invert it, once again, we have 10 to the negative 3rd power. And take a look at our last one. This is 1/10,000th, okay, with a TH at the end because it's smaller than 1. Okay, notice how on our chart it's smaller than 1, and take a look at what's happening to our fractions. So let's take a look at how our fractions become negative powers. Okay, so we have 1 times 10 times 10 times 10 times 10. That's 10 thousandths. Okay, 1 over 10 to the 4th power is how we would write it as a fraction. And if we convert it, it would be a 10 to the negative 4th power. Okay, notice how with negative exponents, the absolute value of the exponent tells how many decimal places, not how many zeros. Okay, so I don't have 4 zeros over here. It's just 3 zeros because I'm moving my decimal place 1, 2, 3, 4 places. That's why there's a negative 4 there, 4 places to the left. Okay, so once again, I'm moving my decimal place from my 1 over 1, which is why there's that 1 there. I'm moving my decimal place to the left twice, so it goes 1, 2. I put my placeholder 0 there, and I have 100. Same goes for 3. I move my decimal place from that 1 over 1, 2, 3 places to the left. That gives me 10 to the negative 3rd power. And again, so this negative is telling me to move my decimal place left from my 1, so I'm going to move it 1, 2, 3, 4 decimal places over. So you can write this decimal as a fraction. This is what this would look like. Would it be easier to write it like this, or would it be easier just to write it like this? It would be 10 to the negative 7th power, 10 to the negative 9th power. We're moving our decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 places over to the left. And that's why we move our decimal place to the negative 9th power. Now we're going to move our decimal point 9 places to the right. What we need to do first, we need to start with our 1 million. Okay? We're going to start with writing out how many 9s there are. How many 10s there are. And here, our absolute value tells us that there's 9 10s. So that's where I'm going to start off with 10 times 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 10. Okay, now I'm going to write 1 billion as a power of 10. Now that I have my power written as 10 to the 9th power, number 4 says, look at the table of the previous page. Write 1 over 1 billion as a 10 to a power to complete 7 times 1 over 1 billion. So 7 times 10 to the negative 9th power would be my answer. Let's take a look at number 5 and number 6. It says, look at solve it. Okay, so right up here. When you have to move the decimal point to the right to express a number of scientific notation, will the power of 10 be positive or negative? And our answer is negative. Okay, and then when we write scientific notation, a non-negative exponent means that the number is at least 1 and a negative exponent. And that means the number is between 0 and 1. So we write this in standard form. Now, explain how to write 2.14 times 10 to the 5th power. We move the decimal place 2.145 places, or we're moving 2 and 1400ths, 5 places to the left to get 214 thousandths. Now to wrap it up, do number 10 and 11 and we will go over it in class.